All right, so it's 12:02, so we're going to get started here. Thank you everyone for coming to our February virtual presentation. So for those who don't know me, I am Matthew Wu, the current president of the ITE Greater Vancouver section. Thank you for joining us. Before we get going, I'd like to acknowledge that I'm located in Vancouver today. This land is located on the traditional, ancestral, and unceded territory of the Coast Salish peoples, including the territories of the Musqueam, Squamish, and Tsleil-Waututh nations. As we are meeting on this virtual platform today, I would like to invite you to take this moment to acknowledge the importance of the land wherever you are attending from. So we have two upcoming events to announce. On March 6th, which is next week, we have our ITE Greater Vancouver and PIBC, the Planning Institute of British Columbia, Joint Mixer and Trivia Night, sponsored by B&A. This is at the Pint in Gastown. Sign up is available on our website. We also have on April 9th, our Mavis Johnson Award for Road Safety recipient, the BC Ministry of Transportation and Transit, presenting on the Highway 99 roundabout turbo reconfiguration. Registration will open for this event next week. Also want to announce that the ITE Canada 2025 conference is hosted in Halifax this year. Registration is open and it'll be from June 1st to 4th. So with that, I want to introduce our speaker, Dr. Stephen Wong. Dr. Wong is an assistant professor with the Department of Civil and Environmental Engineering at the University of Alberta, and he leads the Resilient and Sustainable Mobility and Evacuation Group. His research focuses on the intersection of disasters and emergencies, decision-making, transportation, and he works to create a resilient, environmentally friendly, and equitable transportation systems. He is involved in multiple committees at the Transportation Research Board related to resilience, strategic management, and young professionals. The ITE Greater Vancouver section is happy to welcome Dr. Wong to share a bit of his ongoing research. And with that, I give the floor to Dr. Wong.
Wonderful. Thank you so much for the invitation, and thank you all for being here. Just gonna make sure I can get my settings right. There we go. A little bit different on my end to just kind of see everyone. All right. So thank you all again so much for having me. I'm excited to be talking a little bit about resilience and transportation, and I'll be going through a little bit of the research that we're doing here at the University of Alberta and trying to connect this to where I see the future of practice going. And I actually have a few examples of current practice that we're starting to see in the field, mostly from the US, but it's starting to percolate into the Canadian context as well. So I do want to acknowledge that this a lot of this research took a really village of support. Some of the research was conducted at UC Berkeley when I was a PhD student. So I want to give a huge shout out to those affiliations that I had. Of course, I'm at the University of Alberta now as an assistant professor, and I really want to give a particular shout out and really high praise for the RESUME group, the Resilient and Sustainable Mobility and Evacuation group. It is a collection of incredible graduate students and undergraduate students doing this really hard work in resilient and sustainable transportation. And their work and what you see here is going to be highlighted. And so I really want to give a huge shout out to them on that. My outline of my presentation is I'm going to first just get everyone on the same page when it comes to resilient transportation. What does it mean for us? How do we think about it? And then I'll launch into what is some of the current research that we're doing. If you attended the ITE virtual symposium, you might see a few similar projects that might have arisen from that. But I'm going to try to keep it to more of what we're doing right now and hopefully kind of the emerging research that's going on. And then I'm going to try to connect this to future practice as best as I can. I don't know if I have a crystal ball on what will happen, but this is just kind of the trends I see moving forward. So a key question is, what is resilience? When you think about resilience, what word do you think about? Do you think about being robust or being redundant? Do you think about being flexible or integrated? Are you able to withstand any type of event that comes your way? And a lot of these different types of synonyms and attributes are part of the definition. I like to kind of focus on the transportation element, which is the ability and capacity of transportation systems, associated infrastructure, and also non-related infrastructure, or related non-infrastructure, to mitigate, prepare for, respond to, and recover from both acute shocks and chronic disruptions. So oftentimes when we think about resilience, we think about the shocks immediately. We think about the devastating wildfires that we saw in Los Angeles. We might even think about the earthquakes that you have experienced in the Vancouver area in the past few days. These are more shocks to the system. But there's also more long-term disruptions, different types of, for example, winter weather events. You could consider congestion as a form of disruption that is continuously happening on a regular basis, or even nuisance flooding that arises from sea level rise can cause disruptions on a regular basis. So there's these two elements that are important to consider, but the key with resilience is that the focus is on the shock or the disruption, which is why I have it highlighted here. So why should we consider resilience? Well, resilience is really important for a variety of different reasons. Of course, the biggest one is that we are surrounded by hazards, and British Columbia in particular really knows this. It's no stranger to different types of hazards, whether it be earthquakes, mudslides, landslides, flooding, or even wildfires. And this goes across all different places around the world. When we have these significant hazards, one of the key ways that we protect people is we evacuate people. And especially this is the case for acute shocks to the system, think wildfires or flooding. And it's incumbent upon us as transportation engineers, planners, and policymakers to facilitate this type of evacuation process, whether it be to provide the analysis for it or to provide recommendations for it. There's also a really strong component of transportation infrastructure protection. If we're designing new roadways or we're thinking about retrofits to our transit system, we have to think about ensuring that our infrastructure is protected. Is, for example, SkyTrain protected from an earthquake? Is there opportunities to ensure that it has operational resilience in the face of different types of disasters? There's the last two are more elements of longer term thinking. So the long term economic safeguarding, as well as prosperous and prepared communities. When the 2021 floods happened in British Columbia, a lot of the rest of Canada was cut off from goods movement coming in and out of the port of Vancouver. And so that creates a lot of economic uncertainty and challenges that exist. And we need to be thinking about our infrastructure and how it can either help communities or make it more difficult for communities to survive and thrive in these types of events, and also as well recover well. The good news is that the practice and transportation practice is actually starting to move in a lot of these different directions to address of why we are needing this resilience planning and thinking. Over to the right is an example of a map that came out of some of the work that I did as a sub-consultant as part of a project in the Ojai Valley in California. And they applied some standard four-step modeling approaches using their travel demand model for the region to try to understand which roadways might be overcapacitated in the event of a wildfire. In this case, the wildfire is kind of originating right in the middle of that map in that kind of area. And we were able to identify which roadways are going to have this overcapacity issue where we're going to see a lot of congestion. And this is starting to help when it comes to evacuation planning. And so a lot of this large scale evacuation planning across a region or an area is starting to occur. Community wildfire protection planning is also quite common, as well as vulnerable population assessments, which I had the opportunity to do for a variety of these different communities listed here, most in California, but it's also starting to percolate to other places like Colorado. So this is the more large scale side of practice, and these are all examples of places that have either finished their evacuation planning or analysis within the practice field or are in the process of doing so. But there's also this element of a little bit more at the development level of the need for evacuation planning, analysis, and requirements for either building out developments or retrofitting certain types of developments. And so I had some examples in Redwood City. There was a school that was looking for an expansion in Oakland, California. And also San Diego County is trying to come up with metrics to guide developers in how they might create a new housing project or a new development in a somewhat high risk area for wildfires. So in this case, all of this is looking at the wildfire context. So this is happening right now when it comes to the side of resilient transportation planning, and it's only expected to grow, particularly given the context of the recent fires in Los Angeles. So that's the background of resilient transportation and kind of where we're at right now. And now I want to kind of present and go off in a little bit different direction on where can this research be used, and what research are we doing at the University of Alberta that could be useful for some of these planning assessments, some of these analyses, and specifically for recommendations and strategies as we look forward to ensuring safety. So there's a lot of opportunities for this research, and some of these mirror some of the notes that I mentioned in the beginning of what is resilience. And so there's opportunities for research to identify what are the risks to our transportation systems. Is there a risk to our infrastructure? What type of risk is there of landslides and mudslides for some of the interior highways in BC, for example? There's also a really key need for behavioral understanding and inputs. It's one thing to understand the infrastructure, but it's another to understand how people are going to react within this type of environment. There's a need for generalized evacuation patterns. So a lot of times, a lot of communities do not have the sufficient amount of resources or expertise or time to be able to build out their own evacuation plans, to be able to determine what operational strategies they're going to have in their toolkit when that different type of hazard comes through. So it's really important that we develop more generalizable strategies as well as ensuring that there's community context involved. And that community context can be really driven within the responses and strategies. So for example, if you have perhaps a lower income community or a community with lower access to vehicles, your transportation responses and strategies are going to have to be more public transit oriented or perhaps more shared mobility oriented. And finally, there is emerging technology that we have to be considering. There is widespread adoption of electric vehicles, for example, that is just a different type of fuel source that we're going to have to grapple with. There are both benefits and limitations to electric vehicles from a resilience standpoint, but we need to be able to guide that process. And then there's societal changes too, and a broader understanding of the need to connect communities in a much better way and to focus on a more equitable way of thinking about transportation engineering and planning. So with this, my first case I wanted to mention, and this goes first with this risk identification idea, is some of the work that we're doing in terms of LiDAR assessments of roadways. So what we're doing right now is we're taking aerial LiDAR data, which is often open source. This picture comes from open source LiDAR data available in British Columbia. And we're trying to determine possible features of the roadway that could inhibit a successful evacuation. Now, what could inhibit a successful evacuation? Well, bottlenecks is really critical if you have changing road widths, but other things that change on a regular basis, such as parked vehicles. If you have more parked vehicles, it might make it a lot difficult. Even if you have a single double parked vehicle, could cause a lot of challenges for an evacuation. There is also intersection of the roadway with different types of hazards. So in this case, we're looking at wildfires, where the fuel exposure is looking like. Can these different types of vegetation fall onto the roadway? Are there power lines that could fall onto the roadway that could make it difficult? What about discontinuous sidewalks, ensuring that if you are only able to walk or you have to walk to a pickup location for transit, is that accessible for you? And then there's other metrics that we could also look at, such as roadway slope. So we're really doing this at a pretty fine scale. This is an example of Williams Lake in British Columbia, and you can see the blue the fuel here, which is surpasses 5 meters, and we're able to identify these different features of the roadway. And the goal is to automate a lot of this process. The reason being is that we have done field assessments and surveying before. The picture to the bottom left down there is my colleague, Jeremy Halpern, when I was at UC Berkeley, and we were in Kensington, California. We actually went and surveyed every single street of Kensington. It took a very long period of time, but we're out there with the measuring tool and trying to identify where the bottlenecks are on the road system, because there's a lot of one-way roads, a lot of pinch points in this community, and it's in a really high fire risk area. So what we're able to do is create these maps to the right where you're able to identify these roadways that have these really critical pinch points directly from field survey data, not just relying perhaps on network data that exists out there. This is really going in and identifying what are the barriers to the evacuation. So this process of using LiDAR would really help speed up any type of risk identification. And we could tailor this process to different types of hazards depending on what the needs might be. And so we can see that this could be perhaps beneficial from a flooding standpoint, even in the development of digital twins, for example. The second case I wanted to mention is related to that behavioral data, behavioral input side. This is joint work currently being done by UBC and the U of A. And I want to give a huge shout out to Ehsan, who is a PhD student at UBC, as well as Dr. Amy Kim, my collaborating co-PI on this work. And what we're doing is, on my side, on the behavioral side, I was able to sample about 2,800 people in Alberta and British Columbia on intended evacuation choices. It's one of the largest data sets we've been able to get in the field, and we are trying to identify what choices people will make. Will they decide to evacuate? What time of day would they evacuate? How long it would take them to do so? Where are they going? What mode? What route? All these key transportation questions. And what we can do is we can assign some of this behavior directly to agents in an agent-based modeling setup and simulation. And the simulation allows us to have a closer inspection of key bottleneck locations in which we can create these improved strategies for infrastructure development. So this is an example to the right. This is some preliminary results. So you can see how these agents are showing up and spawning on different points. Where they're spawning and at what point in time is very much driven by the behavioral research that we were able to conduct. So they have a little bit more of behavioral realism. In this case, all traffic is flowing towards Banff. There's an assumption of a fire originating from the south of Canmore towards the city. And so you can start to see how this is moving through in this example of Canmore, and how you can see the red agents are experiencing some delay and some travel time challenges as they move through this system. So I think this is a really great example of how we can bring together different fields, in this case, traffic simulations and behavioral modeling, into a more coherent as well as realistic structure. This is one of the best simulations I've seen so far out there for evacuations. And so I've been really grateful to be part of this process. And again, thank you to the UBC team on the incredible work that they're doing on this. And so from this, we're able to get these, again, maps. So instead of those static maps from LiDAR, in which we just see what the hazard is, in this case, we get to see a little bit more of the transportation questions, in this case, flow to capacity ratios. And you can see in this picture to the right, some of these darker red areas are where we're going to see some of the delays that are and higher levels of congestion, and where we might need to locate perhaps RCMP officers or identify better ways for signalizing that intersection, and perhaps having someone there to direct traffic. And so this is a very useful tool for us to identify where there might be challenges. The third case is looking at more of these generalizable evacuation patterns. So this is ongoing research related to the 2023 Alberta wildfires and the 2024 Jasper Complex wildfire, and we experienced. And so a lot of this is focused on a post-disaster reconstruction. I would like to point out that a lot of this was actually inspired by your ITE president, Matt Wu, who did a lot of this work when he was at the University of Alberta and developing these kind of evacuation curves. In this case, we were able to leverage de-identified aggregated network mobility data from TELUS. And this data was really helpful because it was able to identify when devices entered or left certain geographic areas. So if you put this geographic area around Jasper, you're able to identify how many devices have left and at what period of time that they have left. And you're also able to devise origin destination pairs as part of this data. So you can see of the people in Jasper, how many went to specific locations, for example, in BC, since everyone was sent out towards the west side and all the other roads were closed. So it's really helpful also in calculating these evacuation time estimates, which a lot of communities want to know is how fast is the fastest way I can evacuate my community. And in this case, you can see these normalized curves that occur And you can see how different communities might face different evacuation patterns, but this is a helpful tool to start using with. We're then able to match these different curves with different cumulative density functions, which allow us to capture a departure rate, which then can be fed back into that simulation model I just showed in case 2. So you can see how all this data is starting to pull into as inputs into our simulation processes. And we can see evacuation time estimates about 6 to 10 hours for these more autocentric smaller cities that actually experienced an evacuation. And so this might be the fastest you might be able to get out, and trying to get anyone out faster might be take additional strategies and operational questions and needs. Case number 4 is thinking about, well, from this post-disaster data, we also get a lot of additional behavioral insights. And so I was able to capture a lot of choice making from post-disasters in Southern California, Northern California, and the Carr wildfires. So that's completed research. But we're also in the process of collecting data from the 2023 Alberta wildfires and the 2025 Los Angeles wildfires that just happened. And we can use this behavioral data for a variety of different things. We can use it for descriptive statistics or even choice modeling, which helps identify what influences certain choices. But the key here is that instead of asking, what do you plan to do? This tells us what people actually did, which is very helpful information. Now, of course, the sample sizes are a lot harder to achieve, but we can still get a good sense on what people are doing. And just kind of 3 transportation responses and strategies we can start to think about that came out of this was that some of the results identified that mandatory evacuation orders are very effective, and we've known this for decades. But what was interesting is that we found that people who were evacuation reluctant responded better to evacuation orders. So in other words, if you give someone who's reluctant to evacuate an evacuation order, they really do start to shift their perceptions and their ideas and perhaps get them to actually evacuate. If you give someone who already is evacuation keen, then it's not really going to help them much more. It could provide information, but it's not going to convince them anymore. So what this says is that we need to be strengthening our evacuation order language to denote these risks, specifically targeting people who might be more reluctant. And this could require going door to door or providing very specific outreach depending on community organizations. So for example, previous evacuees and lower income individuals tend to be more evacuation reluctant from our modeling approaches. So you might need to be increasing not just the orders, but also those resources. And the second part of this, some of the results, is we identified that people are making evacuation choices jointly. In other words, people's departure time is correlated with where they go. And where they go is correlated to how bad the fire is around them and kind of the height in which they are evacuating at. And what we ended up finding in some of the key strategies that came out of this work was that we really need highly localized transportation responses that are also available at all times of day. A lot of these cases in these wildfire evacuations, they occurred during night. And so people were evacuating at nighttime. It was a very immediate evacuation. They didn't have much time to prepare, but they weren't going very far. And this is a big shift from hurricane evacuations where we get a lot of our information from. And so these highly localized transportation responses are really great and really critical for getting people out of their immediate risk area. This also might require some demand side changes too. Vehicle reductions could be on the table or be necessary to reduce that congestion. It might be not taking every single vehicle or towing every single toy behind, which is really hard to convince people to do, but is shown, including in simulations, that this can be very effective. But this could also mean pre-positioning vehicles in nearby areas, allowing people to move certain assets as needed prior to the evacuation, assuming that we know that the hazard is coming. The third result that came out of this research was that context does matter for certain transportation choices. So when it came to departure time, people who experienced pressure from neighbors or who had higher visibility or saw the fire were all more likely to choose that departure time. So if you're not seeing the fire, people are not really interested in departing at that time. And that pressure from neighbors is particularly important because it might tell us that we might need to leverage social networks in disseminating information. If neighbors are really keen in convincing others to evacuate, then we need to leverage those different networks and encourage, not just encouraging people to evacuate, but also ensuring that people have the resources to be able to leave. So that might mean encouraging people to check on 3 to 4 neighbors, who, especially those who might need additional assistance. Context also mattered for route choice. And so we found that if you had a lower distance of the route and less fire danger on the route, that you're more likely to choose that route. So that this means that we need to be setting quick and low danger evacuation routes with sufficient resources. So that might mean tow trucks and fuel resources for gasoline powered vehicles or mobile charging units for electric vehicles. It's making sure that the resources are available on these routes that people are preferring. The last set of cases is related to emerging technology. And I mentioned electric vehicles in that last section really briefly, but what we're doing here at the U of A is we're looking at what people's behavior, charging behavior is going to be oriented for electric vehicles in disasters. And these actions can help us identify what the electricity demand is going to be on the grid and where it's going to occur. What we ended up finding in our preliminary work, and we're starting to build some agent-based modeling out of this, is that there is probably going to be a multi-pronged surge in demand that is occurring, that is happening spatially. We were surprised that people were not all saying, I'm going to charge at home. There was actually a lot of people who said, I'm going to charge at public stations, but that is going to probably overwhelm those station capacities, especially given the current infrastructure. And so we're seeing these massive spikes in electricity demand that are occurring, but then there's this really long tail, which indicates that people are still trying to charge over a long period of time, which is a key challenge and might make it harder from a risk standpoint. My case 5B here is something that we have been really pondering here at the U of A, and this perhaps might have the most connection to some of the work that you all are doing as part of your jobs, is thinking about what does a resilient roadway or resilient street design look like, and how does this interface with land use? So with new requirements as well as guidelines as it relates to complete streets and a real need for complete streets when it comes to a safety and sustainability element, there's a lot of questions on ensuring that these complete street mechanisms are also resilient. And so we were able to start to identify co-benefits and tensions that exist with complete streets and resilience. And there's this idea about flexible infrastructure design. And you can see the pictures down to the right on where we have these typical travel ways that are being across this kind of 62-foot section of roadway, but then has flexibility in the case of an evacuation in which these bike lanes as well as the shoulder could be used as an emergency vehicle lane, or you might be able to even do contraflow where all more lanes are leaving the affected area. And so there's flexibility in the design. Of course, this requires a lot of operational changes and behavioral inputs as well as information to individuals, but we need to be thinking about how to make guidelines in the long run for different types of agencies to be able to put onto their roads in their communities. So this is a really interesting idea that we're still pondering, and we've only done very preliminary work on this. So there's some partnership opportunities. If you're interested in this area, please let us know, because this is a key area that we think is going to be perhaps the most useful from a practice standpoint, especially on like what we need to do. It's no longer kind of thinking about what are the risks, but like what do we need to do on a regular basis. All right. So with all that research, you can already start to see how this is connecting to practice in some ways. And I think that last example might be the most closely related to updating our guidelines, updating our manuals to be considering resilience as part of it. And so what will the future practice be for resilient transportation? I have a few ideas and then I'll kind of wrap. But the one big thing is evacuation assessment and evaluation is really going to become a key cornerstone that transportation engineers and planners are going to have to be thinking about in the long run. And there has been a lot of precedence in California from litigation that is going to actually require evacuation assessments as part of environmental impact reports. And this is becoming a really key element. And within these litigation, there's almost becoming a requirement for modeling approaches, like the simulation that I showed from UBC. And there's also a need to find some type of minimal impact or to identify strategies to reduce the impact to a minimal level. And this is happening across the state for a lot of different developments. And there's also within this modeling approach, not just the development itself, but a need to consider all the people living nearby. Is this going to make an unsafe situation for those who live in nearby areas who also have to evacuate? Wildfires are, of course, the most prominent one hazard being considered with this litigation, but there is probably going to be need for other key hazards to think about. Flooding, mudslides, landslides, all things from a British Columbia standpoint as well as an Alberta standpoint. So there is probably going to be an increase in a lot of these needs for assessments and evaluations, not even just in large cities, but also across regions. To piggyback off of that case 5 is also thinking about community design and land use. The picture to the right is of the 2023 McDoodle Creek fire in Kelowna, where some of the neighborhoods that were very much close to that WUI interface faced a lot of evacuation and in some cases had some damage or very close to damage. So the key for us is how do we design current hazard-prone communities? How do we design them in such a way and retrofit them in such a way to address change that could occur in the future? So we know that what we see today is probably not going to be the only thing we have to deal with. It'll be other types of unknowns or a change, of course, with our changing climate, some of these intensity and frequency of events might occur. And we'll need to be integrating land use as part of this. It might be rethinking what density means specifically in these hazardous areas, where we might be able to place density, for example, of course, towards transit and in lower risk areas could be really beneficial and kind of even reducing sprawl and other challenges that we have from a sustainability standpoint. So there's, I think, co-benefits to this as well. We might see retrofits as well as adaptation measures, but there might also be managed retreat in certain areas depending on the type of hazard. In the case of, for example, Louisiana, there is some managed retreat going on due to hurricanes and flooding and sea level rise that is already starting to impact us. The next one is protection of vulnerable infrastructure. We have a lot of varied and widespread infrastructure for both passenger and freight transportation. To the left, of course, in Prince Rupert, we have the ports and the railways that occur from that port. And we may need new guidelines for proper design for these different types of hazards, not just the hazard of today, but also the hazard of tomorrow, thinking about the 100 years that we hope these types of infrastructure are able to withstand. We have to put the investment in now. And that might mean higher costs, but it also might mean identifying perhaps co-benefits when resilience is integrated into this infrastructure design. And so we have to be savvy about this. Of course, we can't balloon the costs of our infrastructure to an incredible level, but perhaps even a few percentage, 1 to 2% increases in costs could really yield a more long-term, robust infrastructure that's able to withstand different types of hazards. And finally, we have emerging ideas for multi-hazard planning. We have different hazards that affect different areas, and we need to be able to plan transportation around that. We need to be thinking about other types of weather-related hazards, and then beyond that as well. So cybersecurity, dangerous goods, derailment, earthquakes, and thinking about multimodality and serving underserved populations. These are just some of the few examples that we've been thinking about here at the U of A. The first two in particular, we've actually conducted research already on it, on disaster relief trials. We were focusing a little bit on micromobility and how it can be useful in both relief as well as evacuation, particularly in urban areas. I'm thinking Vancouver in particular for an earthquake. This idea of resilience hubs, which Vancouver also has a concept of as well with their disaster recovery hubs. And so trying to advance this idea of having resilience be embedded in all aspects of society. And then kind of two interesting things that I like to always point out and as kind of innovative emerging technologies. Drones can be used for a variety of different mechanisms. There's also some work right now being done at the U of A that I know about is like thinking about drones as first responders and emergency responders onto scenes. And then digital twinning for hazards. We're starting that with the LiDAR work, but we can start to get a little bit more advanced in that process. So with that, I just want to conclude. And again, I really appreciate everyone having me here. But I hope I've presented a good overview of what the research is looking like right now. I try to keep it very high level, but there's a lot of work that is being done to really address these key challenges that we have for shocks and disruptions. And we're able to conduct this research to gain valuable understanding, information, assess current conditions, but also reconstruct post events to identify what went wrong, but also what went well. And these can be used as inputs, either as directly as results, or can be used to directly inform our simulations and evacuation plans, as well as perhaps guidelines and manuals moving forward. And finally, this has our impact. Agencies and decision makers and the public can receive recommendations and strategies to better prepare for the future. So there's a lot of wonderful research partners and funders in a variety of different places, both in the United States. So I want to give them a shout out, as well as those in Canada, both locally and also federally and provincially. And so we've been really working hard at this. And this is a QR code if you're interested in some of the research that is being outputted. Most of what I presented today doesn't have the research outputs quite yet, but a lot of it is in the works, and there is still over, I believe, 30 different resources available from this QR code on some of the research we've been doing. And we would love to hear from you as well. Feel free to reach out to me by email. We'd love to hear what the challenges that you have or interests you have in resilient transportation, as well as behavioral studies. There is, of course, great partnerships that exist for universities with both municipalities and industry for example, NSERC Alliance grants to really promote the ideas and research questions that you have and really make a really great case for it for this types of opportunities. So with that, I'm going to go ahead and end and hand it back over for any questions you might have.
Thank you, Dr. Wong, for that presentation. We really appreciated all the insights and the local examples. Just want to open up the floor to questions. So if anyone would like to ask a question, feel free to use the raise a hand function on Teams, and I'll call you, or you can leave a question in the chat and I'll read it out. We have about 10 minutes for questions. I see a question from Anne. Go ahead.
Hi. Thank you very much for this presentation. I was working for Alberta Transportation when the Fort Mac wildfire happened, and we had a construction project on Highway 63 south of Fort Mac. So we have heavy equipment. We have heavy equipment. You have fuel trucks, and there were quite a few people in Fort Mac who were unable to leave. So it's kind of one way in, one way out. It's Highway 63. So they didn't have enough fuel. So they went north to one of the reserves, and because we had fuel trucks, we of course closed down our construction project, and we were running fuel trucks through the wildfire area so that people could fuel up. So yeah, I guess it's not really a question, but just a commentary on, how important it is to understand the context of an area. So, if your first opportunity to fuel up is 2 hours away, and you only have a quarter of a tank, yeah, I guess it's part of the communication to local people to ensure that not only have they got their go bag, but that their vehicle is ready to go. Thanks.
Yeah, completely. Fantastic point. And that criticality of fuel to get people out was a concern that came up in one of the communities that we've been working with for one of the projects in Nelson, where a lot of folks there actually keep their cars often at max half filled, quarter filled, and it might take some time for them to get to a gas station, or the gas station more locally might not have fuel or might not have power to pump the fuel. So we need to be thinking about the resilience kind of in advance, and that also goes with thinking about electric vehicles. There's a lot of electricity demand that's probably going to come with it. And the worst case scenario is that we of course don't want people to run out of fuel, but we don't want these vehicles now to block our evacuation routes, either electric or gasoline powered vehicles, because they don't have the fuel, and that can really inhibit the evacuation process. So we have to think of those strategies in advance and think about all the different connecting pieces that align with that. But thank you for that comment.
All right, we have a couple of comments/questions in the chat. I believe the first comment from Bernard Appelson discusses the lane designation and retaining some of the lanes for vehicles on major arterials. Would you be able to provide any comments on that process?
Yeah, I'm just trying to get back to the meeting because I lost where it went. Let me just see if I can get the chat open. See. In mind, the retain key and try to avoid the 10. Oh, yes, please go ahead.
Yeah,
yes,
I mean,
please go ahead.
Often what happens is the, and I think your emergency evacuation comment really brought this to light, is there's the temptation to put bike lanes and everything else within arterials, take some of the arterial lanes away and to actually accommodate cyclists and everything else, versus possibly putting that bike lane on a parallel route and retaining that vehicle capacity. Because if you're in a panic situation and cyclists, it's their only mode of transport maybe, and now they suddenly arrive on their bike lane and find their bike lane's been repurposed to an emergency vehicle lane, that's just unsafe for everyone. And, so I'm just curious as to the comment about retaining your arterial lanes as best as possible, because we don't always think of emergency evacuation in this long-term planning. We think of the day-to-day more like. And you really do, in my mind, end up with a safer situation all round, where everyone knows where they're supposed to go, and there is capacity left on that arterial lane, on that arterial roadway, to actually accommodate these people trying to leave, often in a panic.
Yeah, that's a great point regarding how we might design a roadway to involve cyclists or other modes of transportation. One thing that came up from that same study in California that picture came from was another option in which it was a separated by a shared use path that was pretty wide, and so that you could evacuate with cyclists on that shared use path, separated away from the roadway infrastructure. So to your point, yes, we would probably need these parallel routes that exist and to ensure safety in the event of cycling, especially in more urban environments. I actually heard a story of someone during the Oakland Hills fire. They actually were part of a focus group in our research, and they actually biked from the Oakland Hills fire downhill to escape it because they were caught in traffic. And so different types of micromobility can be really effective. We even see the use of multimodality, walking, biking, used for other types of events. So think the 9/11 terrorist attacks in New York City, a lot of people walked all the way home. And so making sure that we are accommodating those different modes and ensuring those safety is going to be really critical. So that's a fantastic point. And I think a lot of options do arise for how we can think about our roadway design. And so I'm really hoping to see how that plays out in the long run, and almost giving a suite of options and a menu of options for us to think about depending on the context or depending on that specific roadway.
Awesome. Thank you, Dr. Wong.
Yeah.
We have a couple more questions in the chat. There's one from Tessa Williams, who asks, have you done any consultation or research with staff from emergency operations centers post-emergency to learn about transportation needs and operations to improve resiliency?
Yeah, so a lot of the work, some of the work that I did for thinking about sharing of transportation resources came out of having conversations with emergency operations centers post emergency. And so a lot of them saw that having a shared mobility opportunity where you might be able to leverage neighbors, sharing vehicles, or having different types of companies. If you have Uber and Lyft, for example, in your area, then they could be used as a key transportation asset. We've also been doing a little bit of work following the 2023 Alberta wildfires, where we're talking specifically to host communities. So not specifically the communities that were evacuated, but those who had to receive all the evacuees coming. So in a lot of cases, the evacuated communities did quite well getting people out, but then the host communities were sometimes caught flat-footed on, oh, there's thousands of people showing up to my community all of a sudden. I was not expecting that to happen. And so having good communication with that. So we were having a little bit of research. That's some collaborative research with Dr. Tara McGee at the U of A on host communities, specifically high level, Hinton, and Whitecourt. And a lot of those had discussions with fire chiefs and emergency personnel as part of that. So yeah, it's really important to have that direct line of post-disaster construction with and trying to identify what those transportation lessons learned are.
Thank you, Dr. Wong. I think we have another question in the chat from Chris Kulo asking about if any of your research has considered how geopolitics and economic independence plays into transportation resilience planning.
Yeah, so and see the instance to the European Union is planning a railway for the Balkans to compete against non-EU funded railway being built to the region. Let's create alternative modes. Interesting. So I personally haven't done research on this. This has actually been an idea for some period of time where we were thinking about this challenge, and I guess it's of course a hot button topic right now with the U.S. and Canada with tariffs and everything, but I had conversations with some other researchers in the US about how disaster and emergency response policies would either enable people to move between borders either more efficiently or what barriers would present itself. So particularly for folks in the Vancouver area, your safest option might actually be south, depending on what type of hazard it is, or if you have family in that area, is it easy for you to get across the border, depending on what it is. But the other thing is that disasters don't really care what geography exists in terms of political boundaries. They couldn't care less. And so in your case of the European Union, if a disaster does happen, it's not really going to care if it's in one place or another. It can easily span across borders and boundaries. And so a lot of the research that I have done has only focused on specific jurisdictions, but I can definitely see this need for thinking about geopolitics and what that means for different what the hazard is going to be impacting multiple geographies, but also what the response is going to be and perhaps needing this joint need kind of moving forward. So really interesting concept. Haven't looked at it, but it sounds fantastic.
Fascinating. Thank you for the response, Dr. Wong. I think I'll open it up if anyone has any last questions. All right, and with that, we will conclude our virtual presentation. I want to extend just a large thank you to Dr. Wong for presenting on his research. Really appreciate all the insights. I will be sending over a small thank you gift to Dr. Wong, and thank you all for joining us during this lunch break. Hope you all have a good rest of your day.
Thank you, everyone.